Okay, so let's continue talking about this problem. Uh, so far, we've determined that x squared minus 16 is the lowest common denominator amongst all denominators. So from here, we want to multiply it through. Now, it's going to completely cancel with the first distribution if I multiply it in. So I'm just going to have a 2 left over on top for that first multiplication. So we're going to create a fraction here. There we go. Get a 2. And then with the second distribution, I'm multiplying x squared minus 16 over to this guy here. And what's going to happen is a couple of things. You want to remember that this negative sign needs to be distributed to what's left, as well as the 2. So I think of almost this negative 2. You can even write plus a negative if you need to. And what's going to happen is with the x squared minus 16 and the x plus 4, there is an x plus 4, x minus 4 in the factorization of this guy. So the x plus 4 part is going to cancel. The x minus 4 part is going to be left. So if I distribute negative 2 into x minus 4, I'm going to end up with minus 2x plus 8. Okay, so the minus 2 got distributed into x minus 4, the stuff that was left over. Bottom part, x squared minus 16 and x minus 4 will reduce so that x plus 4 is the only thing that's left there. Distributed with the 3, that would give us 3x plus 12. So 3x plus 12 is what we get out of the result of the first distribution. The second distribution, x squared minus 16 completely reduces. We're just going to have a plus 5 left there. Now they may or may not like this this result here. Actually, they're saying completely simplified. Probably if I say submit, they'll say simplify this further, something to that extent. Yeah, so it's not in simplest form. So I need to combine a few things together, meaning, alright, 2 and 8 become 10. So I'm going to have a plus 10. That guy's gone right there. And down bottom, 12 and 5 become 17. Other than that, what can we do? We could pull out a greatest common factor here of 2 with a negative out front. We could pull out a minus 2. But it's not going to give us anything that will cancel with 3x plus 17, because that can't factor any further, and it would have to be something identical to that to be able to reduce. So that will be our final answer. And when you talk about the term simplify, I guess if you compare the original in blue up here to what we got as an answer, this is a lot simpler looking to be something that's the same. It would be a little easier to work with if we had to plug in numbers or whatever. Alright, so we'll see what else we get here for an example. Okay, this is a nice example here. We've got 4 plus 6 over x divided by 1 minus 5 over x squared. With this problem, what I notice is that we have some values here that aren't fractions, but you still got to think about them like they are. You imagine that 4 is 4 over 1. You imagine that 1 is 1 over 1. And then you can proceed just like we have been. If we use that method that they're calling method 2, I don't know if they're going to use that again. We might as well, because it works just fine with these examples. Let's see what they push forward again. They say, look at the denominators that you've got. 4 and 1 have denominators that are 1, which is, just trivial. So they focus on the x and the x squared, and they say, what's the lowest common multiple, or the lowest common denominator? So the most of each type of factor, x squared, is going to be what we have at most in any one of those denominators. So we're making a choice that's equal or larger than all denominators, because when you get to this step, stuff is going to cancel. So x squared times 4 is 4x squared. X squared times positive 6 over x. One of the x is going to reduce, so the one left over will multiply on top with the 6, and we'll end up with plus 6x on top. Down here, x squared times 1 is just x squared. X squared times a minus 5 over x squared is just going to give us a minus 5 because the x squareds will cancel. So when you look at this, there's always the possibility that this could reduce at the end. I could pull out a greatest common factor of 2x. If I did that, I'd end up with 2x plus 3 left inside. But this guy here can't factor at all, so there's nothing that we can reduce. I do know that one of these examples is going to be tricky because it will reduce at the end. I've seen them throw that in there in the mix. But this example should be fine. Okay, here's another one. They may try to use the alternate method on this. We'll see. So let's see what they talk about. What I see with the negative powers, like we've already dealt with, is that we have 2 over x to the third down here. We have 5 over y to the second down here, and then we can work it like we have. But let's check it out. Okay, so on this example, what they'll do is they'll say start off, just like I think the first example from the first video, start off by saying, what are these with positive powers? I'd have x to the third down below here. Underneath the 5 over here, I'd have y to the second. And yep, going for the second method again, they say, hey, what's the lowest common denominator, or lowest common multiple, based on everything you've got? I'd say x to the third, y to the second. There's nothing common there, so at most I've got x to the third for x's. At most I've got y to the second. So it's the product of those two things. So if nothing's related, it's just the product of those however many things you've got. And they say multiply the top and the bottom by that amount. Well, on the top it would just be 1 times that x cubed y squared. So we're good there. And down below, x cubes would reduce, so we'd end up with 2 times y squared. And in the second distribution, multiply this over, the y squareds would cancel. You'd have x to the third times 5, which is 5x to the third. I can't pull anything out of the bottom here. On the top, these are factors, because there's no plus or minus between the pieces. The factors are truly x, 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 y, y. But down below, I've only got one factor, because this plus sign screws it all up. I can't cancel anything based on this plus sign being here, unless there were other identical pieces that were multiplied with all of this. If I could break it apart, factor it down, maybe I could try to cancel something. Like if there was an x in common or a y in common, I could pull it out front and then cancel with one of these x's or y's. But this is a no-go. And it's a very common mistake that somebody would try to cancel or reduce something at this stage, but you can't go any further. It's all done. Okay. So I think we've reached the max time for this video, or pretty much 9 minutes and something seconds. So we'll I guess do a third video so you can see one of these types of problems, because I think this one is designed to reduce at the end, and you need to see how that will work.